right, guys. Just a quick review on gravitational potential energy. It depends on two things. What are they? I know you guys know already. Already talked a lot about the height. The higher an object is, then the more gravitational potential energy it has. And it also depends on the mass of the object. So if we had two objects at the same height, the one with the higher mass would have more gravitational potential energy. So the formula for gravitational potential energy is, and it makes sense from these things, GPE equals mass, right? One of our factors, times height times gravity. All right. So the gravitational constant on Earth is 9.8 meters per second squared. Again, on Earth. So if I drop something out of an airplane, it's going to accelerate every second at 9.8 meters. It's going to go 9.8 meters per second, faster and faster and faster until it reaches terminal velocity. Another thing you need to know about gravitational potential energy, or energy in general, is that the unit for energy is the joule. We abbreviate that with a J. Not in parentheses, I'm just showing you in parentheses, but it is. So you always want to include your units, and this one is abbreviated with a J. Capital. Okay, so how do you calculate gravitational? That's what this G stands for. Potential energy. Well, we already know the formula. We just talked about it. GPE equals mass times height times gravity. All right. So model what's happening. That's the first thing that we're going to do. That is something that we're doing a lot this year. How do we model it? So let's do number one. A weightlifter lifts a set of 1,250 kilogram weights of vertical, or up and down, right, distance of a distance of 2 meters in a weightlifting contest. How much gravitational potential energy do the weights now possess? Okay, so I'm going to draw a horrible little stick figure here because that's how I roll. So this guy with these bulging biceps has lifted this huge weight. How far above the ground did it say? Well, it said 2 meters. And what was the mass? 1,250 kilograms. Okay, so we just modeled what is happening. It says now record your known and unknown variables using correct units. All right, so here are our variables. Our mass is 1,250 kilograms. Notice I'm including the units, like no naked numbers. Our height off the ground was 2 meters. And our gravity on Earth, we know, is 2.8 meters per second squared. So our question is, what is the gravitational potential energy? So does this huge bar have gravitational potential energy at this point? Well, of course it does, right? It's really heavy, has a large mass, I should say, and it's 2 meters off the ground. So calculate it. So I'm always going to write my equation first. That is required, just like in math. All right. Then you are going to plug in the number. So the mass was 1,250 times the height, which is 2, times, okay, now I'm going to allow us to say that 9.8 is pretty darn close to 10 meters per second squared. But I want you to always put the true number here. But we're going to go ahead and multiply by 10. And if you multiply 1,250 times 2 times 10, you will get 25,000. All right. So all these crazy units here, kilogram, meter per second squared, all those come together to equal a joule, what scientists have defined as a joule. So anytime we're finding energy, whether it's kinetic energy, potential energy, the unit is always joules. Now, one thing that is super important that I want you to see is we did number 3, we used the equation to calculate, but to calculate a joule, the mass should be in kilograms and the height should be in meters. So if that is not the case, you must convert beforehand so that you can get or find joules. So be careful as you move through these problems to make sure that they are in kilograms and meters before you calculate.